Hello and welcome. In this video, we're going to be looking at parametric functions and their first derivative as well as the second derivative. So we're going to be learning how to differentiate parametric functions. So to start with, I'm going to give you a quick idea on what exactly are parametric functions. So a parametric functions can look something like this. Say we have a function where we have x, where we have x equals t cubed and we have y equals t power 4 plus 1. What does this mean? X is some function in terms of t, and y is also some function in terms of t. So what happens, or how to plot this parametric curve, is we do something like this. We have a t value, we have an x value, and we have a y value. So when t equals 0, for example, we put in 0 here. We know that 0 cubed is 0, so x is going to be 0. And here we have 0 power 4 is 0 plus 1, so y is 1. So our first point is a point of 0 and 1, and we plot this point 0 and 1 on our curve. The second point is, let's say, when t is 1, so 1 cubed equals 1, so our x is going to be 1, and our y is going to be t power 4 or 1 power 4 plus 1, so 1 plus 1 is 2, so we'll have another point 1 and 2, so 1 and 2, and we will plot our curve that way. This is basically a parametric function. So x is related to some variable t, and y is related to that variable, and so on. Okay, so what if we want to find, let's say we want to find, after drawing the curve, we want to find the differentiation of this curve, or the equation of the gradient. How do we find dy by dx? Okay, dy by dx is basically dy by dt over dx by dt. Why is that so? Dy by dt over dx by dt is the same as divide dx by dt, or basically multiply the opposite, so dt by dx. And here I can see that dt cancels, so this is going to be dy by dx. Okay, so this whole thing is dy by dx. Why do I write it this way? Because it's simple for me to get dy by dt, and simple for me to get dx by dt, and then divide them by each other to get dy by dx. So let's start and see how we can do that. So first of all, let's get dy by dt. So dy by dt is basically differentiating this equation over here. So dy by dt is going to equal differentiation of this, which is going to be 4t cubed. Differentiation of 1 is 0, and dx by dt is going to basically equal the differentiation of this function, so it's going to be 3t squared. So to find dy by dx is basically this over that, so it's going to equal 4t cubed over 3t squared, which is going to give an answer of 4 over 3. T power 3 divide t power 2 is the same as t power 3 minus 2, or t power 1. So our answer is 4 over 3t. And this is how to find the dy by dx. Let's take another example. Let's say we have a function where x equals e power t and y equals 2t cubed plus 3t, and I'm asked to find dy by dx. Okay, so first of all, I know that dy by dx is going to equal to dy by dt over dx by dt. So let me start by getting dy by dt first, which is differentiation of this function over here. So this is going to be 3 times 2 is 6t, and reduce the power by 1, so it's going to be 2, plus differentiation of 3t is basically 3. Let's now get the differentiation of dx by dt. is going to be differentiation of this, and I know that e power x or e power t, the differentiation of that is basically e power t as well. So now if I want to find dy by dx, I'm gonna put dy by dt, which is 6/2 squared plus 3, over dx by dt, which is e power t, and this is going to be my answer for dy by dx. Right. Let's take a look at another example. Let's say we have x equals t squared, and we have y equals 2 sine of t. And now we want also dy by dx. First, we know that dy by dx is going again to be equal to dy by dt over dx by dt. So let's start by getting dy by dt, which is differentiation of this. So I know that differentiation of sine is cosine, so this is going to be 2 cosine of t, and dx by dt is going to be the differentiation of t squared, which is going to be 2t. So my answer is going to be 2 cosine of t over 2t. I can cancel the 2, so it's going to be cosine of t over t, and this is going to be my answer. Okay, let's say we want to find the second derivative. Okay, so when we wanted to find the first derivative, we said that dy by dx is equal to dy by dt, okay, which is basically differentiation of y, which is d by dt of y over dx dt, right? So when we want to find dy by dx, we do the differentiation of the thing that we want to find it. So if we want to find dy by dx, we do differentiation of y by dt over dx by dt. So again, if we want to find the second derivative, okay, we basically want to differentiate the first derivative, right? So we want to do the same, but instead of y, this is going to be the first derivative. So it's going to be differentiation by dt of the first derivative, which is dy by dx over dx by dt. When you compare, you will find that these two exactly are the same, because you want to differentiate y by dx, so you differentiate y by dt. Here you want to differentiate the first derivative by dx, right? So you differentiate the first derivative by dt and then divide by dx by dt. This you can think about it also in another way, which is very similar to what we have done, which is like this. So I know that d of d by dt of dy by dx, okay, divide dx by dt, which is basically d of dy by dx over dt multiply dt by dx. So again, these dt's are gonna cancel, and we will have differentiation of dy by dx with respect to dx, which is basically differentiating the first derivative, which is equal to the second derivative over here. So basically, this over here is how to find the second derivative, and it will make more sense when we try to solve it using the next example. So let's take a look at this example where it says that we have an x that is equal to t squared plus 1, and we have y which is equal to 2t power 3, and we want to find the second derivative, d squared y by dx squared. So first, let's start by getting the first derivative as we've done normally. So this is equal to dy by dt over dx by dt. So let's start by getting dy by dt, which is going to equal to differentiation of this function. So it's going to be 6t squared, and dx by dt is going to equal differentiation of this expression, which is 2t, and differentiation of 1 is 0. So my dy by dx is simply going to be 6t squared over 2t, which is going to give me a value of 3t, because 6 divided 2 is 3, t squared divided t is t. So this is my dy by dx. To find okay, to find d squared y by dx squared, we said it's going to be differentiation of the first derivative expression by dt over dx by dt. So dx by dt, I already have it. It's over here. It's equal to 2t. So what I need to do is I will need to get this part, which is what? Which is differentiation of dy by dx, okay, which was 6t squared, okay, because this was equal to dy by dx, differentiation of that with respect to t. So this part over here is going to be basically differentiation of this with respect to t, which is simply going to be 12t. Okay, so 12t over dx by dt, which is 2t. No, this is dy. No, it's not here. dy by dx is 3t. dy by dx is 3t. dy by dx is 3t. So this part over here should be the differentiation of dy by dx. Differentiation of dy by dx with respect to t. dy by dx is 3t. So differentiation of that is basically 3. Because I just read that this is the dy by dx. However, no, it's 3t. Okay, so differentiation of dy by dx, which is differentiation of 3t with respect to t, is simply 3, and then over dx by dt, which I already have as 2t, so I will just divide them, and this over here is going to be the answer for my second derivative. Let's take another example to make this more clear. Let's say we have x equals e power t, and we have y equals t e power negative t, and we want d squared y by dx squared. So first of all, as usual, let's start by getting dy by dx, which we already know. It's dy by dt over dx by dt. So over here, dy by dt equals is differentiation of this expression over here. So let me differentiate this expression, okay, which is this one over here. I can see that this is a product rule, and by the way, I've done a whole video on product rule, which you can go check out by clicking on the top right hand corner. It's super useful. So the product rule is basically differentiation. This is the first, this is the second. So it's differentiation of the first, which is differentiation of t, which is basically 1, multiplied the second, and then adding to that the first times differentiation of the second. So what's differentiation of e power negative t? Is basically e power negative t multiply differentiation of negative t, which is negative 1. So my dy by dt is going to be 1 times e power negative t, which is e power negative t, and then we'll have minus t e power negative t. This is dy by dt. Okay, to find dx by dt, we'll basically differentiate this expression over here, which is super simple. It's going to be e power t. So if we want to get dy by dx, we're going to divide those two together. So we're going to say dy by dt, which is e power negative t minus t e power negative t, over dx by dt, which turned out to be e power t. This could give us a value of, first I can take an e power negative t out common. This is going to be 1, because e power negative t divide e power negative t is 1, and then minus t e power negative t, taking out e power negative t is basically t, over e power t. So I can rewrite that as, I can remove this e power t to the other side. It's going to be multiplying e power negative t. It's going to be e power negative t multiplying e power negative t multiplying 1 minus t. And I know that since I'm multiplying these two, I can add the exponents. So it's going to be e power negative 2t multiplying 1 minus t. So this is basically dy by dx over here. So if I want to find d squared y by dx squared, I know that it's going to be differentiation of dy by dx with respect to t over dx by dt. dx by dt is super easy. I have it. It's over here. Okay. What I need to do is to find this numerator part, which is differentiating dy by dx, so differentiating this expression with respect to t. So let's try and do that. Again, this is a product rule. This is the first and this is the second function. So it's differentiation of the first, so it's gonna be e power negative 2t multiplying the differentiation of negative 2t, which is negative 2, multiplying the second alone, which is 1 minus t. And then adding to that the first, which is e power negative 2t, multiplying that differentiation of the second, and differentiation of 1 minus t is basically negative 1. So this is gonna be negative, let's multiply everything out. So this is gonna be negative 2e power negative 2 times 1, which is negative 2e power negative 2t, and then negative 2e power negative 2t times negative t, which is gonna be positive 2t e power negative 2t, and then adding to that negative e power negative 2t. So here I can see that this and this, I can add them together, is going to be minus 3 e power negative 2t, because minus 2 minus 1 is minus 3, plus 2t e power negative 2t. So this is basically the numerator part. Let's solve this by dividing the numerator over the denominator, which is, the denominator is going to be this expression that we just got, 2t over dx by dt. And what is dx by dt? It's e power t essentially. So again, I can take this out on top, so it's gonna be e power negative t, and then I can take e power negative 2t out common. So negative 3 divide negative 3 e power negative 2t divide e power negative 2t is basically negative 3, and then this expression divide e power negative 2t is basically plus 2t. So we can multiply these two together by adding the exponents. Is going to be e power negative 3t multiplying 2t minus 3, and this is going to be my second derivative. Okay, let's take another example, which is super important for us, which is over here. Okay, let's say we have this question over here. So this is basically some applications of parametric differentiation. So let's read the question. It says we have a curve C that has a parametric equation in this form over here. It says find dy by dx in terms of t. This is easy, so we can do that just like how we solved the previous one. So dy by dx is going to equal dy by dt over dx by dt. So dy by dt is going to be the differentiation of this expression over here. I know that the differentiation of tan of x is secant squared of x. So the differentiation of 2 tan of t is going to be 2 secant squared of t. And the differentiation of dx with respect to dt is going to equal, this is the same as sine t all squared. So this is going to be differentiated using the chain rule, which I also have a video on, which is super helpful. So this is going to be 2 sine of t, and we reduce the power by 1, so it becomes 1, multiply the differentiation of what's inside. So the differentiation of cosine of sine is basically cosine. t. So these are the two expressions that I have. Dividing them together will give me dy by dx. So let's do that. It's going to be 2 secant squared of t and over 2 sine of t cosine of t. So I can cancel these two out, and I know that secant x equals 1 over cosine of x. Okay, so I can rewrite the secant squared as 1 over cosine squared of t, and then I have a sine of t and then a cosine of t. So I can multiply this cosine squared with this cosine is going to be equal to, let's write it over here, 1 over cosine cubed of t multiplies sine of t. So this is dy by dx. This is the equation of the derivative. Okay, so this is part A. So for part B, it tells me the tangent to C, so the tangent to my curve at a point where t equals pi over 3, cuts the x-axis at point P. So let's say this is my curve C, whatever, this is the curve. It says that let's say this is the point where t equals pi over 3. Okay, it says that the tangent at this point, cuts the x-axis, so this is the tangent that we want, cuts the x-axis at this point P. So I want to calculate the x-coordinate, or where is this point P. So in order to find this point P, I will need to find the equation of this tangent. And this equation is going to be in the form y equals mx plus c. So I will need two things. I will need the m and I will need the c. Okay, so the slope of the tangent, okay, is going to be the same as the slope of the curve at this point. So this I can get it with the help of my first derivative, which is dy by dx, which I got because I know that this is an expression for the gradient or for the slope. So if I replace the t over here that I want, is going to give me the slope at that x or at that t. So let's do that. So it says at t equals pi over 3, dy by dx is going to equal 1 over cosine cubed of pi over 3 multiply sine of pi over 3, because I'm going to replace all the t's with pi over 3. This is going to give me an answer of I will need to make sure that my calculator is in radians. So cosine cubed of pi over 3 multiplying sine of pi over 3 is going to give me an answer of 16 root 3 over 3. So this is my gradient of the curve at this point, which is also the same as the gradient of this straight tangent line. So this is equal to m. Okay, so in order to find the equation mx plus c, I will need a point. I will need a y coordinate and an x coordinate, and I have m. I will substitute everything to get c. So let's get the y and the x at this t pi over 3. So we know that y equals 2 tan t. So 2 tan of pi over 3, when t is pi over 3, this is going to give me what y is at a t value of pi over 3. So 2 tan pi over 3 equals a y value of 2 root 3. And similarly, x equals, I believe it was sine squared. Yes, sine squared of t. So x is equal sine squared of pi over 3. So equals sine pi over 3 all squared. This is going to give me an answer of 3 over 4. So my point, okay, my point, which is at where t equals pi over 3, this point over here has a coordinates of x and y, these coordinates. So it has a coordinates of 3 over 4 in the x and 2 root 3 in the y. So I can use all these points together with the m that I have to get the equation of the line. So y equals mx plus c, so y is going to be 2 root 3 equals m, which is 16 root 3 over 3 multiplying x, which is 3 over 4 plus c. So now I can cancel this 3 with this 3. 16 and 4, this is going to be a 4. So this is going to be 2 root 3 and then equals to 4 root 3 plus c. So if I move this 4 root 3 to the other side, it's going to be 2 root 3 minus 4 root 3 equals c. So this is going to be negative 2 root 3 equals c. So my c is negative 2 root 3, and my function, or the linear equation for my tangent line, is going to be 16 root 3x, 3 over 3x, minus 2 root 3. So this is my equation for this tangent line. In order to know where this tangent line cuts the x-axis, I know that this is going to be at some x value and y value of 0. So if I substitute y with 0, it's going to give me the x value at where this tangent is intersecting the x-axis. So 0 equals 16 root 3 over 3x minus 2 root 3. I will add to both sides 2 root 3, so this is gonna cancel, and here plus 2 root 3. So I'm gonna have 2 root 3 equals 16 root 3 over 3x. I can cancel a root 3 and a root 3. I will multiply by 3. I will divide by 16. So this is going to be 6 over 16, which is equal to x, and this is going to be, I can divide both by 2, so x is going to equal 6 divided by 2 is 3, 16 divided by 2 is 8. So this is the x coordinate where my tangent line cuts the x-axis. So this video was how to solve and get the first and second derivatives for a parametric equation, which is an equation in terms of t. It gives you a function of an x and y, both in terms of t. I hope this video was helpful. Please don't forget to like, subscribe, and comment any questions or topics or suggestions down below. I see all the comments and I will reply to them. Thank you so much for watching, and have a nice day.